So hi everyone, I am Subhadip. So today in this video I will explain this question, and this question was asked in 2024 JEE main on 30 January shift 2. So before going to this question is actually from Cramer's rule. So let us discuss first what is Cramer rule. So suppose this is a system of equation a1 plus a1x plus b1y plus c1z equals to some d1, then a2x plus b2y plus c2z equals to d2, and a3x plus b3y plus c3z equals to d3. Suppose this is a system of equation with three variables. Now to solve this system of equation, what we do? So this system can be written as matrix form. So suppose this is a1 b1 c1, then a2 b2 c2, and a3 b3 c3, and this is x y z, and this is equals to d1 d2 d3. So if you multiply, then we will get this system, right? Now this system, so for this system we define this delta. What is delta? Delta is nothing but, so if we name this is a and this is capital X, this is suppose capital Y, then if determinant of this a, that means determinant of this, so this is so this is what, a1 b1 c1, a2 b2 c2, a3 b3 c3. This is our del, and we are defining del 1 nothing but replace by this a1 into a3 by d1 d2 d3. So d1 d2 d3 and rest of them are same, d1 b1 b2 b3 c1 c2 c3, right? This is delta 1. And what is delta 2? Delta 2 is similarly a1 b1 a1 a2 a3, then replace by here d1 d2 d3, then here c1 c2 c3. And similarly, what is delta 3? Delta 3 is here a1 a2 a3, and then b1 b2 b3, then c1 c2 c3, right? So this is our delta 1 delta 2 delta 3. Now how we get x? X will be given by delta 1 by delta, y will be given by delta 2 by delta, and z will be given by delta 3 by delta, right? So this is the solution. So if a given system this, then we define this delta 1 delta 2 like this, then we just have to find delta 1 delta 2 delta 3 and delta, then we get x y z. Now there are some conditions. So first condition, when we get unique solution. So for unique solution, if delta not equals to 0, then we get unique solution, right? And so when a solution will be called consistent, if that is a unique solution or infinite solution. That means if it is have solution, then it will be consistent. So this is if unique solution, then it is consistent also. So for second case, when no solution, so no solution is, so suppose delta is 0, but at least one delta I, that means at least of these three, delta 1 delta 2 delta 3, at least one is non-zero, then we say that this system has no solution. And for the third case, when infinite solution, if we get delta equals to delta 1 equals to delta 2 equals to delta 3 equals to 0. So if this happens, then infinite solution. And for first case and third case, we will call the system is consistent, and otherwise for second case we will say that this is inconsistent system. So this is the basic for Cramer's rule. Now let us look at that question, what is given here. So first of all, here our system is x plus y plus z equals to 5, then x plus 2y plus lambda square z is 9, and then 3 x plus 3y plus lambda z equals to mu, right? where this lambda mu belongs to our real number. So let us find the delta first. So delta is what? Our delta is our determinant of this is 1 1 1, then just put like this. So 1 2 3, then 1 lambda square lambda. Now if we expand this, what we get? So 2 lambda minus 3 lambda square, then so 1 into, then minus 1 into lambda minus lambda square plus 1 into 3 minus 2. So this is 2 lambda minus 3 lambda square minus lambda plus lambda square plus 1. So this is equals to, so minus 2 lambda square, then plus lambda plus 1. So we can write it as minus into lambda 2 lambda square minus lambda minus 1. So these things can be written as minus 2 lambda square minus 2 lambda plus lambda minus 1, right? So this is equals to 2 lambda minus of 2 lambda, let us take common 2 lambda, then what we get? Lambda minus 1 plus 1 into lambda minus 1. So that is minus of lambda minus 1 into 2 lambda plus 1. So these things we get. Now, so when this solution will be unique, so solution will be unique when, so we have to find this lambda, this should be not equals to 1, and also lambda should not be minus half. So if not equals to, so if we got these two, then it will be unique solution. So let us check the option. So unique, for unique solution, lambda not equals to 1 and mu not equals to 3. So even if it lambda equals not equals to 1, but if lambda equals to minus half, then it will be it will not give unique solution, right? So lambda not equals to 1 and also lambda not equals to minus half, but this condition is not given here. So this is not true. So actually here we have to find which is not correct. So the option 4th is correct. Option 4th is our right answer. This statement is not correct, but this is our right answer. But so this will be the answer, but we will check all the options here. So for the option, and so for, let us look these two options. So for these two options, it is given that lambda equals to 1. For first and second option, look, this is lambda equals to 1, lambda equals to 1. So let us put lambda. So when lambda equals to 1, when lambda equals to 1, then what will be the delta will be 0. Now if we find some delta 1 is non-zero, then we will say that this system is inconsistent. And so for the first case, so mu is 13. So what will be lambda delta 1 is, so our delta was what? Delta was this 1 1 1 1 2 3. So delta 1 will be replaced by this 5 9 mu. So this will be 5 9 mu, then 1 2 3, and our lambda is 1, so this is 1 1 1. So this will be 5 into 2 minus 3 minus 1 into 9 minus mu plus 1 into 27 minus 2 mu. So this is equals to minus 5 minus 9 plus mu plus 27 minus 2 mu. So this is minus mu plus this will be 13. So minus of mu minus 13. Now if mu not equals to 13, lambda equals to 1 and mu not equals to 13, then what will happen? Then at least one we get non-zero, at least one delta 1 we get non-zero. So for this case, the system will be inconsistent or no solution. Inconsistent or no solution. So lambda equals to 1 and so this option is correct. This statement is correct, but here we have to check the statement is correct. So this statement is correct. Now if mu equals to 13, then what will happen? So if mu equals to 13, then lambda 1 will be 0, and you check yourself that lambda 2 and lambda 3, this will also be 0 when lambda is 1, when lambda is 1 and mu is 13, right? So this option is also correct. This statement is also right. And for that case lambda not equals to 1. So if lambda not equals to 1, if lambda not equals to 1 and lambda not equals to half, then it will be unique solution, so then it will be consistent, it's okay. But in worst case, what will happen? Lambda is not equals to 1 and lambda is minus half. So for that case, what will happen? So when lambda is 1 and lambda is minus half, this is the worst case, because if lambda not equals to 1 and lambda not equals to 1, lambda not equals to 1 and lambda not equals to half, then this option is okay, this statement is correct. But in worst case, what will happen? Lambda not equals to 1 and lambda equals to minus half. So if this happens, then you check the lambda 1. So what will be the lambda 1? Lambda 1 is, sorry, delta 1 is this is 5, 9, and for that option mu is 13, right? So mu is 13, so here is 13, and then this is 1, 1 2 3 1 1 1 1 2 3 1 1 1. So this will be 5 into 2 minus 3, then minus 1 into 9 minus 13, then plus 1 into 27 minus 26. So this will be minus 5, this will be plus 4, and this will be plus 1, so this will be 0. And also you check lambda 2 and lambda 3, this will give you 0, right? So when this lambda not equals to 1 but lambda equals to half, and also this 3 is 0, that means there are infinite number of solutions, so the system is consistent for the last case. So this is also right. So these three statements are correct, but this is not correct, this statement is not correct. So our which option is correct? So this fourth option is correct, since this is not correct, right? So thank you everyone for watching this video, and if you have any doubt you can comment down below, and also if you like this video you can share with your friends. And thank you everyone once again. Bye.